All right, guys, good morning. It's Wednesday, April 1st. No joke. And we're getting started on 11.7. Hopefully you guys all got the email. Tomorrow, on Thursday at 11 a.m., I'm going to be hosting a Zoom meeting, my first ever. Actually, it'll be my second, because today I'm hosting one with my Math 1 class. So tomorrow will be my second Zoom meeting. First with you guys, Math 2. Hopefully you guys will all check in, help me out. I'm sure I'll make some mistakes, but it'll be our first trial run. Come on in and help me figure it out. All right, hopefully I'll see you tomorrow at 11 a.m. right here in my dining room, right there in your living room. Okay, let's get started on a few problems off of worksheet 11, worksheet 7. There are 4 questions on the front, and there are, looks like 2, 4, 6, 8, 9 on the back. I'm going to do a couple off the front for you and a few off the back. Okay. So, find all solutions to f of x equals g of x. Solve by graphing, and B, solve algebraically using substitution. All right, so let's look at our two functions. We have f of x and g of x. F of x is a linear equation, and g of x is a linear equation as well. So where they are equal is where they intersect. Okay, we did this back in Math 1, believe it or not. So if we graph both of these, hopefully you guys remember for f of x, your slope is 2, and your y-intercept, called at B, is negative 5. So if we have a y-intercept of negative 1, 2, 3, 4, 5, and a slope of 2, which is rise 1, run 2, we get this line right here. I'm going to find a straight edge so I can plot this guy for you. Hang on a second. There's a post-it note. That'll work. And let's see if I get that just right. Okay. So this is f of x right here. And g of x, let's see, g of x, oops, sorry, not f of x again, g of x has a slope of negative 1/3 and a y-intercept of 2. So there's your y-intercept of 2, and a slope of negative 1/3 would mean down 1, run 3, down 1, run 3, and we can already see where they're going to intersect. They're going to intersect right here at where do they intersect? They intersect at 3, 1. Okay, now you don't have to do this, but I want to point out, let's plug in 3 for x and 1 for y in both these equations. So f of x, I'm going to change that to a y. And if we plug in 1 for y and 1 for y and 3 for x, let's see. Okay, I got that. Here we go. So we plug in 1 for y and 2 times 3 for x minus 5. We end up with 1 equals 6 minus 5, which you can see 1 equals 1. So you can see the point 3, 1 makes f of x true. Now if we plug in 3, 1 for g of x, so this is y, remember it's the same as y, so we plug in 1 equals negative 1/3 times 3 plus 2. We get 1 equals negative times a positive is a negative, and 1/3 times 3 is 1. And 1 plus negative 2 is 1. So you can see that the point 3, 1 makes g of x true as well. Okay? And that's the whole point. This is the only point that is on both lines. So it's the only ordered pair that will make both f of x and g of x true. Okay? Now let's show it algebraically. And it's pretty simple. We just set the two equal to each other. and we go 2x minus 5 equals negative 1/3 x plus 2. Okay, remember, whenever you want to get rid of a fraction in an equation, just multiply it by the common denominator. Okay, so we get 3 times 2x is 6x, 3 times negative 5 is negative 15, equals 3 times negative 1/3 is just negative x, and 3 times 2 is 6. Now we're going to add x to both sides, and we get 7x minus 15 equals 6. We add 15 to both sides, we get 7x equals 21. Divide both sides by 7, and we get x equals 3. Okay, well, now, since we know x equals 3, we can plug x into either one of these, and we've already done that. Y equals negative 1/3 times 3 plus 2 means y equals negative 3. Let's see, negative 1/3. Negative 1 plus 2. Y equals negative 1 plus 2 is 1. So when x equals 3, y equals 1. Okay, so we showed this graphically, and now we showed it algebraically. Okay? I'm going to leave number 2 for you guys. It's another set of linear equations. I think you guys can handle that. And I'm going to do number 3 because all of a sudden you're going to notice something different, aren't you? We have a, what is that? That's a quadratic function and a linear function. So let's graph that real quick, and let's see what we got here. So g of x is probably going to be easy. We got a y-intercept of 4 and a slope of 3, which means rise 3, run 1. We can do the opposite and go down 3 over 1, and we get this graph, or this line right here. So let's draw that. And when you draw your lines, make sure you go across the entire graph. Okay. Now, let's go ahead and plot f of x. And you know what? Probably the easiest thing to do here is, we know this guy opens down, and we should know that our vertex is at what? Well, this is x plus 0 squared and 4, so we know our vertex is at 0, 4, and it's right there. And we know it opens down, okay? So I think we should just do, the easiest thing to do is just do a t-chart for x and f of x. And let's plug in, let's plug in 1, 2, and 3. Because when we plug in 1, we know we're going to get the negative 1. And when we plug in 2, we're going to get negative 2 because your vertex is on the y-axis. So we plug in 1, we basically get negative times 1 squared plus 4. Well, 1 squared is 1, and 1 times negative 1 is negative 1 plus 4 is 3. So that means x, when x is 1, y is 3, which means we have those 2 points there. So our parabola is starting to look like that. Let's plug in 2. Well, we have negative 2 squared plus 4. Okay, 2 squared is 4. Okay, and 4 times negative is negative 4, and negative 4 plus 4 is 0. So when x is 2, y is 0. So our parabola is traveling further down this way. Let's plug in 3. Negative times 3 squared plus 4. 3 squared is 9. 9 times negative 1 is negative 9, and negative 9 plus 4 is negative 5. So when it's 3, it's negative 1, 2, 3, 4, 5. And again, we know it's also negative 3. And look at that. So our parabola goes just like this. So hopefully you can see that our parabola and our line are actually going to intersect in 2 points. At 0, 4, and at negative 3, 1, 2, 3, 4, 5. At negative 3, negative 5. So 0, 4, and negative 3, negative 5. And you know what? We could plug 0 in for f of x and 4 in for x, and we would get something true. We could plug in 0, I think I said that backwards, would be 4 for f of x and 0 in for x, because 4 equals negative 0 squared. 4 equals 4. And 4 equals 3 times 0 plus 4. So that's a pretty easy one to see, but you can see it makes them both true. All right, now algebraically, let's see what we got here. I'm going to go 3x plus 4 equals negative x squared plus 4. Okay, and you guys might see that I did that for a reason. Okay, here's what I'm going to do. I'm going to add, put everything on one side, so I'm going to add x squared to both sides and minus 4 to both sides. Ooh, minus 4. 4's all cancel out, don't they? And we end up with x squared plus 3x equals 0. Okay. Well, how are we going to solve this guy? You guys might not see this, but we can factor out an x, and we get x times x plus 3 equals 0. Factored an x out from both of them, because x times x would be x squared, and x times 3 is 3x. So I just factor out an x. Remember, that's called GCF. Well, the great thing, it's this times this equals 0. A times b equals 0, which means either a has to equal 0 or x plus 3 has to equal 0, which means the two solutions are x equals 0 and x equals negative 3. Okay? Look at that. Boom. Okay? So now with two solutions, we can plug them back in. We can plug them both back into either one of them. Let's take g of x because it's the simplest. 3 times 0 plus 4. Well, when x equals 0, y equals 4, but look at that. We already knew that, didn't we? And we take g of x again, and this time we plug in negative 3, and we get g of x equals negative 9 plus 5, and we get negative 5. But again, we knew that already too. And it didn't matter that we picked g of x. I picked g of x to plug x's back into because it's just easier. But if you plug back into here, it's going to be the same thing. All right, guys, I'm going to leave number 4 for you and number 2 for you to do. Let's go on to the back. All right, so now we're just solving all of these algebraically, and it's really not too bad. Once you set them equal to each other, get them all to one side, set it equals 0, and then decide how you're going to do this. So let's see. I'm going to go x squared minus 4x minus 5 equals negative x minus 7. If I add x to both sides and I add 7 to both sides, we end up with x squared minus 3x plus 2 equals 0. Okay, now we got to decide how are we gonna solve this, and I think this one is factorable. Okay, because x minus 1 times x minus 2, x times x is x squared, negative 1 times negative 2 is positive 2, but negative 1x plus negative 2x is negative 3x. Set each factor equal to 0. And when we solve, we add 1 to both sides, we get x equals 1. Add 2 to both sides, we get x equals 2. Okay? So, now, when x equals 1, what does f of x equal? Well, negative 1 times 1 is negative 1, plus negative 7 is negative 8. Okay, and plug in 2. 2 times negative 1 is negative 2, and negative 2 plus negative 7 is negative 9. So those are your two solutions. Alright, I'm going to do one more. Let's see if we can find one that might be a little trickier. Oh, let's do number 12. That one might be tricky. I don't know. We'll see. So let's set them both equal to each other. So we get x minus 2 squared plus 3 equals 2x minus 4. Alright, well we're going to have to multiply this out, and it's x minus 2 times x minus 2. We know it's x squared minus 4x minus, no, plus 4 plus 3 equals 2x minus 4. Now, did we have to go through that? I think we did. So now we'll subtract 2x from both sides, and we'll add 4 to both sides. And we'll add 4. So we get the x squared, and then negative 4x plus negative 2x is negative 6x, and 4 plus 4 is 8, plus 3 is 11. And that equals 0. Okay. Well, let's see what we got going here. We can't factor this, but we can complete the square. So I'm going to go x squared minus 6x plus some number equals, move this over, negative 11 plus some number. Well, half of negative 6 is negative 3, and negative 3 squared is 9. So we get x minus 3 squared equals negative 2. Okay, well, going to come out with an I think. We take the square root of both sides. I'm going to bring it up here. We get the square root of x minus 3 squared is x minus 3 equals plus or minus I root 2. Add 3 to both sides. We get x equals 3 plus or minus I root 2. Okay? Alright, so we've got our x value. We solved for x. Okay? All we're looking for, thank goodness, is the value of x here. Find the value of x for which f of x equals g of x, which is nice because plugging back in to find our y value would not be very nice here, would it? Alright, so there's your answer. Okay, I'm going to leave the rest of those for you guys to do. Good luck.